Good morning. Thanks, Sunil, for the introduction, and thanks to Ugam for having me at this awesome event. It's beautiful here. So as Sunil mentioned, I sit on Forrester's Customer Insights team. So I write my research across verticals for a specific role, and that person is, like a lot of you based on your introductions, people have access to mountains of customer data and are trying to discern insights from those data to help you better win, serve, and retain customers. And when I joined Forrester about 3 years ago, my original beat at Forrester was customer analytics. So there was a lot of talk about segmentation yesterday, so behavioral segmentation is one of the things I get the most calls about. Predictive analytics, predicting who's going to churn, predicting cross-sell and upsell propensities, calculating customer lifetime value. And then about 24 months ago, it became pretty obvious that AI was going to enjoy an extended spring and maybe even summertime. And so it was kind of a natural fit for me to take on our initial AI research because of my background in machine learning and data science. And as we'll see today, that's a core piece of AI. So today we're going to talk about that. We're going to talk about the shiniest of shiny objects today, which is artificial intelligence. And we'll look at some successes in the application of AI and also some failures, and I'll give you some things to think about as you think about deploying AI. But since it's early, I thought I'd start with something fun. When people think of AI today, the manifestation of AI, I think we've gotten a little more sophisticated than immediately thinking of the Terminator or maybe HAL. We're probably have reduced our expectations to something that's more like a chatbot. So I'd like to here, for the first time, give the Best Bot Award to this company that is tackling an incredibly serious societal problem with a really interesting technology. So the bot is called Rescam, and the company is called NetSafe. It's actually a New Zealand-based nonprofit focused on online safety. And what they're focused on is this really persistent, pernicious problem of email scam. So basically what you do is if you get an email scam, say from a Nigerian prince, and Sunil mentioned I did the Peace Corps, so actually when I'd email home, I'd be sitting in a cyber cafe with a bunch of Nigerian princes. And you know, the email may say, "Good day, please reply to this email with the details requested so that we can proceed with funds transfer. Thanks." You can email this to Rescam, and Rescam will actually pick up the conversation and mess with this person and waste their time with reply messages like, "Hi, okay, that makes sense. How soon can I expect to receive these funds? I owe a pretty significant amount of money to Reader's Digest and need to pay them back before they take legal action." So I like this one a lot. So that's AI. Now, what is AI? We have about 40, maybe 50 people in the room, which means we probably have 80 or 100 different opinions of what AI is. Forrester's definition is the theory and capabilities that strive to mimic human intelligence through the process of experience and learning. And I think there are really two core facets of this definition. The first is the mimicry of some human faculty, and we can see the different human faculties here. Sense, there are AI component technologies that sense. We'll look at some of those that think or reason about what they've sensed, and then there are those that actually take action on the world. The second facet is this learning. That's really key for me, is that AI systems may react to a situation today much differently than they did yesterday based upon the data that's accrued in the meantime. So let's look at what some of these technologies are. We'll start with those that sense or help perceive the world around. So here we see an image, and we're figuring out, okay, what is the likely emotion of these people? Well, that's a specific type of image and video analysis. Image and video analysis, these technologies allow you to bring images to the table, and then they will classify those images. It was long an impossible task because images, of course, aren't structured row and column data, but thanks to deep artificial neural networks, we can start to actually classify images today. And some vendors like Google has AutoML are actually making it relatively easy for you to bring your own images to the table. I think they say you need a minimum of 100 images to categorize a specific category in a very drag and drop fashion to create your own models for image recognition. Facial recognition, which is kind of what we have here, is a very distinct use case for for image recognition, of course, the biometrics that are now enabled on the iPhone 10 that recognize your face, that would be facial recognition. Emotion recognition is a subcategory of that, which is what you see there. Affectiva it has been one of the leaders in emotion recognition, and they're OAMing their solution in a number of different products. One is called HireView. So if you are a job candidate and you have a video interview with the company you'd like to hire or who'd like to hire you, Affectiva or HireView will actually tell the interviewer the emotions that you're feeling during the course of the interview, as if interviewing wasn't stressful enough, right? Another one, probably more relevant for you guys, is a company called Cloverleaf that creates end caps for retail, well, mostly grocers, but I could see it being in any retail, that actually has a little camera in it, and based upon the type of people who are walking by, will automatically adjust the display in that end cap to get that right message in front of the right customer in the store experience. Speech analytics, you're all aware of Alexa. Let me get a show of hands. How many people are satisfied with their Alexa use? Okay. Dissatisfaction? Yeah, my own satisfaction in Alexa has steadily declined. I've had really high hopes, especially because we keep feeding Alexa better speech data, so she should get better at understanding us. But I think that there are still considerable hurdles to make her commonly used. But anyway, Alexa is speech analytics. Speech analytics is also particularly useful in the call center to either take transcripts make transcripts of calls and do text analytics on those to see, okay, why are people calling in? Is there a way to potentially proactively stop people from having to call into the call center? And then also mid-call as well. There's a company called Cogito that actually will give the call center representative feedback on their own emotion and the customer's emotion in real time, so they can course correct if that conversation is going off the rails. And finally, text analytics. Text analytics is actually kind of near and dear to my heart because I did a lot of text analytics before I joined Forrester. And when I was doing it a number of years ago, it was very much rules-based. So you had to really know what you were looking for in text and then create these very robust, yet often brittle rules to find those themes, those topics, those entities. Today, text analytics is getting a bit of a facelift thanks to machine learning, and in particular deep learning, which actually allows the machine to engineer those rules by itself. You still need a set of training data, so I don't think rules-based text analytics is going away, but if you use machine learning on top of it, you get higher accuracy and certainly higher efficiency. And we've actually seen in our research that more companies are now analyzing their customer text data, whether it's from feedback from email or chat, or from transcripts of phone calls, or maybe even social media today than ever before. About a third of companies are doing that, which was about a 10% increase from the prior year. Let's talk about AI's ability to think. So machine learning is typically at the brain of most artificially intelligent systems. Machine learning platforms are these software or libraries of machine learning algorithms. There are many different types of machine learning algorithms. Deep learning, artificial neural networks, a type of machine learning. They deserve kind of their own call out because they do something quite special. But in classic machine learning, you have classification like decision trees. You have clustering models to find different maybe segments of customers, often used in customer segmentation. Association analysis, you guys would probably know as market basket analysis. All of these classical machine learning systems. Now, the one thing that I want to make clear here is that the algorithms get a lot of the hype. The algorithms are really sexy. But the algorithms you can access in open source in R or in Python, or you can use a proprietary tool like SPSS or SAS. The algorithms are pretty much commoditized. It's the data that you feed into an algorithm that creates a model. So your differentiation from machine learning is actually going to come from your data. I can't stress that enough. It's really not that much about the algorithm. Everybody has pretty much the same access to the same algorithms, except for maybe Google and Amazon. Deep learning, this is a convolutional neural network here. You have an input layer. You have these hidden layers in the middle that are made up of perceptrons or neurons, they're sometimes called, and then the output layer. So we were talking yesterday about how people always use the image of cats as an example. So I don't want to fall victim to that. So maybe images of hamburgers. And then in these hidden layers, they're actually picking up on features that say, okay, this is a hamburger. Like maybe this is the bun layer, and maybe this is the meat patty layer. Maybe this is, there's ketchup on it. Actually, it's probably more like, okay, here's what the edges look like. Here's what the shading looks like. But through a process called backpropagation, the network actually figures out, okay, what are the key ingredients of a hamburger, and gets really good at predicting whether an image is a hamburger or not. And until recently, we couldn't really use deep neural networks, not because they didn't exist. They've existed since the 1950s, but because we didn't have the compute power to train the algorithms to do what we want them to do. And also we weren't applying them to unstructured data like images. Now we have GPUs, and it makes this process a lot more efficient. Finally, action. What are the technologies that help us act? Well, one of the main ones is natural language generation, which is if you're in a conversation with a chatbot, instead of just yelling into the wind, you actually get a response. The machine is actually generating a response. Many of these were actually initially adopted to feed in like a box score from a sporting event, and then automatically create a news article on that match or game, as if journalists didn't have it hard enough these days. And then finally, there are a few solutions in our research we identified that combine all of these elements to some extent. They sense, they think, and they act. So if you think about the previous technologies as technologies or components or building blocks of AI, well, these actually fulfill the requirements of being AI in the sense that they're, to an extent, continuously learning. So one of these is AI-enhanced analytics solutions. So BI tools like Tableau or Cognos, pretty commoditized feature-wise at this point, but they've realized that by employing elements of AI, natural language understanding, the ability to automatically identify anomalies that a user may be interested in, they can get some differentiation. So we're starting to see partnerships between Tableau and automated insights, and we're seeing some companies build this into their BI solutions natively. Conversational service solutions, and would be a good example of this. These are customer service chatbots, essentially, and there's a whole suite of technology providers who specialize in just this. This is most enterprises' first foray into AI, I would say, are these chatbots for customer service. Intelligent research solutions. Here, these are solutions that are disrupting traditional market research and allowing folks to actually have a conversation with a chatbot about their experience rather than answering survey questions to get a more nuanced view of what the customer experience is, what's driving that customer to buy or churn or have a different experience. Intelligent recommendation solutions. So we're going to see kind of like one of the most popular recommendation engines in a second, but most recommendation engines rely on something called collaborative filtering, which says that if Mary and I look alike, you're going to show me content that Mary has engaged with. These go beyond that. Sometimes they're using image recognition to actually show me, let's say, shoes on Zappos that look like other shoes that I've seen. So it actually doesn't have anything to do with the user. The recommendation is totally based on the image. What does the heel look like? What type of material is it? What color is it? And then pre-trained vertical solutions. Pre-trained vertical solutions is kind of a catch-all category for any sort of plug-and-play machine learning where you don't actually have to do the training yourself. So Watson for oncology, for instance. IBM bought up all these medical imaging companies so they could train Watson to identify cancer from those medical images. There's another great company based here in California. It was a young kid at Stanford created something called Do Not Pay. Have you guys heard of Do Not Pay? So if you get a parking ticket in the United States, or I think the UK, you can submit it to Do Not Pay, and Do Not Pay has been trained in all of the municipal parking code in those two countries to actually fight your ticket. And something like 76% of tickets get some sort of reduction by using this service. So anyway, that one's pretty interesting. So not all of these technologies are created equal. This is Forrester's tech radar construct. Basically, we plot them by, on the y-axis, we have the business value add, so how much value is the adoption of these technologies adding to the businesses which adopt them. And then on the x-axis is the ecosystem phase. How mature is this technology category? Now, this being AI, everything's kind of shifted left since it's a relatively nascent category overall. You can see machine learning platforms is kind of up on the top on that blue trajectory there. Well, that trajectory says we think machine learning platforms is having and will continue to have significant success. We're already seeing massive gains from the deployment of machine learning, especially in customer analytics, predictive analytics, customer segmentation based on clustering analysis. Whereas here, we've called out deep learning platforms, which are still relatively new. I mean, TensorFlow would be a good example of a deep learning platform. They could add value. The problem with deep learning is you actually have to bring your own corpus of data to the table to train the system, and that corpus of data has to be correctly and consistently labeled, right? So you have to have a bunch of pictures of hamburgers that are correctly labeled hamburger or not hamburger. So that's why this is, the onus is on the company to bring their own training data to the table. Here, some of these are already trained to a certain extent, although as you probably know, you'll have to customize them to your own specific business needs. So let's look at what some companies are doing with artificial intelligence. So I mentioned recommendation engines before. This is my Netflix home screen from a few days ago. So Netflix is obviously using machine learning collaborative filtering to determine what content to recommend to folks. The reason I bring this up is because Netflix is particularly good at doing something they call exploring and exploiting, explore and exploit. So basically they exploit the fact that potentially Sunil and I look alike, and so they'll show me content that Sunil has also engaged with and other people who look like us, so that's the exploitation. But they also explore, meaning they sprinkle in random content, like this Trump documentary. I'm not gonna watch that, but they wanted to see if potentially that was something I'd engage with, and then they would show it to Sunil and other people who look like us. Without that constant kind of testing, AI can become very narrow very quickly, and you may miss out on other potentially more optimal opportunities. So that's why I bring Netflix up. I'm also going to bring up Coca-Cola. I know we have someone from Coke in the room today. I'd be interested to see how widely adopted this is, but basically Salesforce rolled out image recognition for Coke products within Coke refrigerators, so that now a technician can go and take a picture of a Coke refrigerator, and image recognition will automatically count the inventory that's left in that refrigerator to make reordering automatic. And it takes into account on the back end things like seasonality, whether there are any large consumption holidays coming up, like say March Madness, to order optimal inventory without actually having to manually count the bottles. Covergirl, does anyone else use this app? Just kidding. Covergirl's custom blend app uses AI to find the right foundation. So it uses computer vision or image recognition to identify what your skin tone is, not just your overall skin color, but also the intensity of your skin, and then the undertone of your skin, to find a custom blend that you can then order through the app for foundation. This is one of my favorite cases for a couple of reasons. One, Farmstead, this company based here in the Bay Area, is a grocery delivery company. It's an app, and their mission is to reduce food waste. So I think something like 38 million tons of food are wasted every year because it goes bad on the shelf. And so they're using AI to help optimize their inventory when it comes to how much food, how much of each SKU to order. And what's interesting with them is, first of all, they've done a very good job of that, so I like their mission, but it's an interesting case study in trusting the machine. Their CEO was doing all of the ordering to begin with, and they built the algorithm to predict every user's likelihood to buy individual SKUs. And so they had the algorithm, but the CEO wasn't willing to turn the reins over to the algorithm, because what if something goes wrong? But he kept testing side by side his own predictions versus the algorithm's predictions. And it wasn't even a competition. The algorithm slaughtered him in terms of accuracy. And so slowly but surely, he gradually turned over the reins 100% to the algorithm. So now this algorithm that's predicting inventory makes 100% of those orders. So those are some successes, some things to consider. I mentioned deep neural networks. They're great for images, speech, and to a certain extent text, so taking unstructured data and turning it into structured data, but they are inherently opaque. If you remember, there was input layer, output layer, and then in the middle, hidden layers. They are essentially hidden. You could actually probably write out all the math, but it would take up all of these walls. But if you need to show your work, if you need to show how you arrived at a decision, I always think of banks and deciding whether or not to extend credit to someone. You probably can't use a deep neural network, so keep that in mind. Second, and you probably are aware of this example, these models are only as good as the data used to train them. I just published a report on the ethical implications of AI and how bias can unintentionally seep into artificial intelligence and the algorithms or the models that are the brain of these systems. This is a notorious example because Microsoft was really happy to unleash Tay on Twitter and have users interact with Tay. Now, as you all know, we don't, as a species, really put our best foot forward on Twitter. And so Tay soon, within 24 hours, became what the Telegraph in England called a Hitler-loving sex robot. So Microsoft had to take Tay down. And since they've tried to make adjustments and retried this with a little bit more success, but still not completely successful. So you have to be very careful in what you're feeding into these systems, and you have to absolutely continuously monitor, especially if the systems are continuously learning from new data. And finally, I think that the most common failure today when it comes to AI is just trying to do too much. With AI, these systems are really good at taking on very narrow tasks, but when you try to create something akin or close to pure or general AI that could interact with people and hold different topics and streams of conversation in their head, it's going to fail. And I know Facebook is here, but this happened last year. It became apparent that the Facebook Messenger bots hit a 70% failure rate, meaning that only 30% of inquiries were actually able to be completed or resolved by the bot. The other 70% had to go to humans, and that's because they had kind of this grand design to be able to develop a conversational platform to handle any situation. But unfortunately, it lacked the ability to understand context, to hold different conversational streams at the same time. For instance, up here you see, do I need a jacket? The bot fields that question, well, yeah, it's chilly outside. But then if the person just asks the word sunglasses, the bot was unable to retain the thread of the previous conversation. And so it made a little joke like, you gotta wear shades. So now Facebook has decided to focus on a narrower set of use cases so users aren't disappointed by the limitations of automation. And that's what I would advise you to do. And so here are some of my recommendations when it comes to thinking about these technologies. The first thing is, don't do AI for the sake of AI. It's bound to end in failure. There are some problems, business solutions that are particularly suited for artificial intelligence. There are some that aren't. There are some that rules-based systems will be able to handle quite well, actually, and be much simpler and less expensive to implement. Start with a business problem or a business objective. Are you trying to win more customers? Are you trying to grow the lifetime value of the customers that you already have and nurture loyalty, improve the customer experience, stave off customer retention? All of those things are places to start. And then before you start thinking, okay, now I know that, like, let's turn to AI, actually turn to your data and take a careful inventory of your data. Data is the lifeblood of artificial intelligence. As we saw, some of these technologies are more data hungry than others. So it behooves you to understand the data that you have that you can use to potentially train one of these systems. If you're in a data sparse environment, you're probably going to have to go with something that's more pre-trained. If you have a wealth of data, building an AI system on your own data is always better than something that's more generic. So I would recommend going that route. Select a narrow use case based on the overall feasibility and try to prioritize based on what you expect the overall business impact to be. Yeah, the build versus buy thing. So a lot of folks aren't lucky enough to have machine learning specialists, data scientists, especially folks who understand deep learning. I mean, I used to do this stuff and I've never used a neural network before. If data scientists are unicorns, those people are like Pegasus. They're very, very rare. So if you don't have the skills, you may have to buy a solution for your narrow use case. Continuously measure to make sure that the system is performant and to make sure that it's not going off the rails like Tay did, and measure success. Like Robert was talking about yesterday, I mean, with OKRs, I think it's really important before you even start the project to determine, okay, what is the metric of success? What are we, are we looking to grow our customer base? Are we looking to grow customer lifetime value? Is it some sort of decrease in attrition or maybe a higher NPS score? Figure that out ahead of time and then communicate that across the business, because if you do this right, you will succeed with your goals. You really have to then take that, champion it across the business and say, this is what AI did for us. And I had one other slide that didn't make it in here, but I want to mention, people say, okay, Brandon, this is great, all of this is possible. Are people actually using AI? So according to Forrester's research, we survey like 4,000 global and technology decision makers globally. 52% of companies are currently investing in or using AI in some capacity, and another 20% plan to in the next 12 months. That's very high. I was shocked by that number. But when you look at the geographic breakdown, Asia is like 61 or 62% have already implemented AI. North America is down around 52%, and then Europe is considerably trailing that. And I think a lot of that has to do with the amount of data that's available. Of course, Europe is looking into the headlights of GDPR coming into effect on May 25th. So very stringent data protection there, whereas in Asia, particularly China and India, not that stringent requirements on how data is used. And so I think AI is going to continue to proliferate.